Hi, welcome to ISE503, and this chapter is on database architecture part 1. So let's see what do we have here. If you could remember, in the last lecture I did provide you the definition of DBMS, and in that definition of DBMS it was said that the DBMS is a software package that helps us in defining, creating, using, and managing database. And in the definition, we said that this software package has a number of modules. This is complex. DBMS is not a very simple software. So here we will start with this thing. If you're looking at this picture, which says the architecture of DBMS, then from this picture that we have in this slide, you can get some idea about the important components of a DBMS. So let me make this statement over here that although we have a very nice picture to understand the important components of DBMS, but this is not universal. It all depends on a specific vendor who is coming up with a database management system. But these components we will find in most of the database management system. So let's have a look at this architecture. So here I'll show you in picture what are the important components, and then the remaining slides will discuss these components in more detail. I would request you to pay attention on this part where I'm putting a tick mark. So these are the different ways in which we could interact with a database management system. And if you could recollect from the previous lecture, we did discuss different kind of users who would interact with DBMS, right? So there we had the database designer, DBA application, database application programmer. Okay, so there are different kinds of users. They will interact with DBMS in different ways. Therefore, a good DBMS, like as you can see over here in this box, that's called the DBMS interface. So in the DBMS interface, database management system provides the different ways in which someone can interact with this system, with the DBMS. So we can, the DBA, database administrator, can make use of data definition language, DDL statements over here, to provide the data definition. Similarly, someone could be a DBA or any other database management system user can interact with the DBMS using the interactive queries as well. And a very well built, I would say medium sized database application will interact with the DBMS through the embedded SQL statements. So the applications will also interact with the DBMS, and they may interact slightly differently. And similarly, we can have some APIs as well. DBMS may support some APIs for interaction with the DBMS, and that API can be used in the application. Now, the DBMS also provides some database tools. These could be some utility tools to monitor the performance of DBMS. So fine, we did look at the DBMS interfaces. Now let's look at the other components in this big box, big rectangle that you're looking at. Here we have some very important components like the connection manager, then we have security manager, DDL compiler, database utilities. Then you'd see a big rectangle over here that has been labeled as query processor. And finally, we have a storage manager. In query processor, you would see that we further have some smaller components like DML compiler, query parser, query rewriter, query optimizer, query executor. Whereas in the next module, which is a storage manager, we have these components like transaction manager, buffer manager, log manager, and recovery manager. Now what is left to be explained is this part over here. So guys, I'm not explaining over here, just giving you some overview about these components, right? The details we are still to discuss in the next slides to follow. Now, well, what do we have in the database? In the database, you will have the raw data, it will have the catalog, and will also have the indices. If there are some indices built, then yeah, those index or the indices are also stored in our database, just like a data. All right. So now in the next slide, you would see these important components listed over here: the connection and security manager, DDL compiler, query processor, storage manager, DBMS utilities, and DBMS interfaces. So let's dive deeper in these components and learn about those in more details. So we will start with the first component, which is very important one, and this is called the connection manager. So what connection manager does, it provides the facility to set up a database connection. Now when we say database connection, then yeah, we need to include both the possibilities. The database connection may be established locally on a local machine, or it can be established remotely to a different machine, maybe a different database server you may call, through the network. So both the possibilities are there. But yes, we do need connection manager so that the connection could be established or could be set up with the database. Now, this connection involves the information about login credential. So whenever the connection is to be established, then the connection manager will verify the logon credentials, and if the credentials are correct, then only a connection handle will be returned. Now it depends. The database connection can either run as a single process or it can run as thread within the process. Now the connection manager also takes the help of security manager. So let's see what security manager does. The security manager verifies whether the user has the right privilege. So if you remember, in the previous chapters, we have learned about the advantages of a DBMS. And one of the advantages associated with the database management system is that it will provide us the support for security, right? And for security, we did look at these measures like, authorization and authentication. So the security manager is over here, which will verify whether a user has the correct privilege or not. As an example, right? The user may be given only the read privilege, and the attempt is made by the user to write, right, or update the data. So that should not be allowed. It all depends on the kind of privileges assigned to a user. So security manager will verify whether a user has read or the write access. If it is a read access, then the user can only read the data. If yeah, and for writing, the user should have the write access. All right, so let's move on to the next module. The connection manager and security manager are and their roles are kind of intuitive. Now let's move on to DDL compiler, a very important component. So what it does? Well, it compiles the data definition which are specified in data definition language. DDL stands for data definition language. Now here again we'll have to remember a few things that we learned in the previous chapters. We did learn about data model, and they were what? The conceptual data model, a logical data model, internal data model, and the external data model. So ideally, what is required? Ideally, we would need three data definition languages, three DDLs. Why? Well, we would like to have one data definition language to define the internal data model, the other one for logical data model, and the third one for external data model. But in practice, like in most of the DBMS systems, like relational databases, where they use SQL, then SQL comes with just one data definition language, and that DDL will have the set of instructions um, for defining the internal model, set of instructions for logical model, and set of instructions for the external data model. So that is in practice, but I would say these things are kind of vendor dependent. Okay, so what's the next bullet here? It says that DDL compiler will first parse the DDL definitions to make sure that they are syntactically correct. Syntactic, I believe you people know about it. There should not be any syntax error. Okay, so that thing is checked by the DDL compiler. That's the first thing it will do, and after that what it does, it will have to translate the data definition into an internal format, and if there are some errors, then yeah, it will generate the errors, but the errors are generated only if there are some syntactical or syntax issues. If not, then it will convert or translate, you may say, the DDL statements into the data definition, and which will be stored in the catalog. Okay, so which I have in the next bullet. It says that upon successful compilation, the DDL compiler will register the data definition in the catalog. Right, so you need to remember the important role that catalog is playing. Okay, so maybe you would like to finally make a note where you would put everything together, like in what are the different roles or what are the responsibilities that the catalog holds. Okay, done with these three components. What components we saw? We saw the connection manager, security manager, and DDL compiler. Now let's move on to the next component, which is query processor. Now query processor helps us or assist in the execution of database queries. Okay, and these queries will be for the data retrieval, data insertion, data update, or data removal. All right, so yeah, you need to distinguish the role of the DDL. So DDL compiler. Okay, so DDL compiler we learned in the previous slide. It has to deal with the data definitions, which are written in data definition language, whereas the query processor we have deals with different kind of queries. You'll see that very soon. We will get into data manipulation language, DML. All right, so from SQL, which is a very popular language for relational databases, we can broadly categorize these statements in the SQL into the data definition language statements and the DML language statements. So here the query process that we are discussing deals with the DML kind of queries. So the query processor assists in the execution of database queries, and these queries are for retrieval, insertion, update, or removal of data. Now, interestingly, the query processor, which is a very important component in the DBMS itself, comes in further smaller components. So let's look at the key components of the query processor. When I put stars, that means it is important. So the key components of the query processor are DML compiler, query parser, then we have query rewriter, then query optimizer, and finally query executor. So if you want to count, there are 5 components in query processor. Now let's look at the role of these components in the query processor. And then what DML compiler does, the DML compiler compiles the DML statements, and before we get to more details of DML compiler's role, let's spend some time in in learning about the types of data manipulation languages or DML. So the first type that we will look at is the procedural DML. Alright, so when somebody is saying procedural DML, then we need to understand why are we calling it procedural at the first place. So, in procedural DML, the DML need to explicitly specify how to navigate the database to find the data. Okay, to do whatever we want to do with the data, right? And if you remember, we need to retrieve, insert, update, or remove data, right? These things we may like to do with the data in DML. So in the procedural kind of DML, we need to explicitly specify the procedural details. Okay, so you may use the term like procedural detail as well. So in procedural DML, we need to explicitly specify how to navigate in the database, and because of that reason, and how is that thing done internally, well, we make use of the memory pointer, and the memory pointer will point to one record at a time, and after retrieving that record, or after updating, deleting, whatever we want to do with that record, the memory pointer will move to the next record. So because of this procedural nature, we can work on one record at a time on procedural DML, which can be thought of as a bottleneck of procedural DML. So in fact, the first bullet that we have here is also a bottleneck, because you need to explicitly provide the details of navigation to the data in the database, and then it is going to be a one record at a time. And then the final thing is that we don't need any query processor for the procedural DML. Why we don't need that? Because we are taking responsibility of the navigational details, therefore query processor is not required here. Now we will look at the second type of DML. Here we have declarative DML. Okay, so these concepts could be interesting and important at the same time. You need to highlight the difference between the procedural and declarative DML. Now, in declarative DML, DML specifies what data should be retrieved and what changes should be made. This is declarative, right? Declarative means we do not provide no procedural details. So in fact, the SQL structured query language that we will be learning in the next chapters, probably in 4 or 5 lectures from now, or maybe 2 to 3 lectures from now, we will start learning about SQL. So SQL language is in fact a declarative language. Okay, and in the declarative language, we specify what data should be retrieved, or what changes should be made on the data. We do not specify, we do not give the procedural details. We don't need to provide how to navigate to the data, navigate in the database to retrieve a specific information, or to modify specific I should not say information, rather I should say specific data, or modify the data, or a group of data. Okay, now one advantage with the declarative DML is that it is set at a time. Compare this point with the record at a time. In the procedural DML, we can only process one record at a time, because we are making use of the memory pointer, whereas in case of declarative DML, you have this flexibility that you can work with a set of records at a time, not a single one. Could be 1, 2, 3, 4. It all depends uh, on the data, how much data satisfies the query, and the nature of the query as well. Okay, so that is an advantage of the declarative DML. Then the third point that we have for the declarative DML is that here we need a query processor. All right, so the first 2 points I'll consider as the advantages of declarative DML over procedural DML. The third bullet, I don't want to call that as a disadvantage, but it could be an overhead. But this overhead helps us a lot. It makes our task of programming a lot easier, a lot convenient, a lot efficient. Okay, so what I'll do here, I'm showing you a snapshot of a program which is written in Java. My intention is not to explain the whole program to you, and don't worry if you don't know Java. The main reason of putting this slide here is to give you some idea about how an SQL statement would be. I should not say SQL rather, because we did not start learning about SQL systematically. I should say DML, right? So data manipulation language has been embedded in this program. So the whole program that you're looking at is written in Java, and Java is what? The host language. Is the host language here. We have a bunch of statements like try and catch block. We are not going there. We don't need to get lost there. What we need to focus on is this part over here, which is in bold, and that too in the red. All right. So what is it? Well, this is a DML statement. Okay, DML, SQL DML statement, which says select e.name, d.name from employee department D, where e.dnr is equal to d.dnr. Don't worry about it. This is simply a data manipulation language statement that has been embedded in the Java program. Now, the role of the DML compiler would be to extract this statement from the host programming language and look at its correctness. DML compiler will again convert that into the intermediate representation, will check for the errors, will check for the syntactic error, will check for the semantic error, so on and so forth. Okay, so one of the reason why we have this program over here in the slide is to give you some idea about the role of a DML compiler. It has to extract the DML statement from the program which is written in the host programming language. Now, let's discuss about another very interesting issue that gets involved when we have a scenario like this. What do I mean by scenario like this? Well, when we are using a host programming language, and that host programming language is interacting with the database using the language provided by the database, like the DML provided by the database. So this problem is called impedance mismatch problem. So let's see what is this whole problem about. So in this back to this example, right? We are using Java programming language as a host programming language, and Java is an object-oriented programming language where the data is is mostly represented in the form of objects, right? And for objects, you'll create a class and all. So the data structure would be kind of an object in the Java programming language. Well, we can have even more complex data structures, but here I'm thinking of the very basic data structure or the way data is represented. Whereas if you consider about the way data is stored in the relational database, again we need to understand what relational database is, but don't worry about it. What I want to communicate is that data in the relational database is stored as a table. So let's look at it, right? So impedance mismatch refers to a problem which involves or which needs a mapping between the object-oriented domain or paradigm like Java and the relational concepts. So data in relational databases is represented. Relational, when we are saying, then we are referring to SQL. So in relational databases, the data is represented in tables, whereas in object-oriented programming languages like Java, data is stored in the objects, and these are different. Objects are not similar as tables. Okay, so yeah, there is this problem involved which needs a mapping between the object oriented concepts and the relational concepts. Now, well, although these are challenges, but we do have these solutions. So let's look at the impedance mismatch solutions. How can we overcome these problems? So, we can use a host language and the DBMS in such a way that they have comparable data structure. All right. So in that kind of solution, we will not use relational databases or relational DBMS. In place of relational DBMS, we will use object-oriented database management system. Now, if you have the host programming language like Java, which is object-oriented, and your DBMS is also object-oriented DBMS, then yeah, the problem is solved. Okay, we have the compatible data structures here. And the second solution is to make use of middleware, and the middleware will take the responsibility of mapping the data structures from the DBMS to the host language and vice versa. So here we did not say RDBMS, we just said DBMS. And we did not say Java. In place of Java, we have used host language just to keep it more general. Okay, and both the and yeah, this is still valid for the example that we had for Java and relational DBMS. This could be important. Okay, so in the next slide we have an example to give us some idea about impedance mismatch. Impedance mismatch. How come? Look at it, right? In the relational approach, the data is stored in a table. Okay, so we have a table that is storing the information about an employee, and here you're looking at the DDL, data definition language statement from SQL, which we are using to create a table named employee with these columns or the properties: employee ID, name, gender, and the department number. Now, in the relational database, in the relational DBMS, the data would be stored in this format, in a tabular format, okay, with the rows and columns. Whereas if you have to write the similar program, similar concept to, if you have to do similar thing in Java, and where you want to store the information about an employee, then in place of the table, you'll create a class. You'll say public class employee, and then for employee you will go on, for this employee class you will go on and declare your data fields, right? We call those data fields. So employee ID is the data field which will have the employee ID information, then you have the name, then gender, then department number. And interestingly, for classes we can have the methods as well, right? So we have the getter method, get employee ID, we have a setter method, set employee ID, we have getter for name, we have setter for name. Okay, so the reason or the message that I want to give you through this slide is the difference between how the data is stored or data will be stored in Java programming language versus how the data will be stored in the relational DBMS. Okay, these are different. Table versus an object or class. Okay, so that is simply the impedance mismatch problem. All right, so back to DML compiler. What DML compiler does, DML compiler starts by extracting the DML statement from the host language. Then what DML compiler will do, DML compiler will have to collaborate with other components of query processor. What are these? Query parser. Then there is query rewriter. We have query optimizer, and we also have query executor that will finally execute the DML statements. Okay, so it is possible that the DML statement that we are trying to run or compile may have the error. So errors are generated. If the errors are generated, then that will be reported. Now let's look at the query processor. We have kind of seen what DML compiler does. Okay, so query parser, what it does, query parser parses the query into an internal representation format. Okay, and then a query parser will check for syntactic and semantic correctness. All right, so this kind of thing was being done for data definition language statements by DDL compiler. But here, the syntactic and semantic correctness would be checked by query parser. So this thing you need to remember. This is not done by DML compiler. DML compiler will simply extract the DML statements from the host language. Now, fine, right? We are done with the query parser. Let's see what this query rewriter will do. Now, the query rewriter component that we have will optimize the query rewrite, right? So it will rewrite in such a way that the rewritten queries are more efficient. Now, one interesting thing about the query rewriter is that it will optimize the query, but this optimization happens independently of what? The current state of database. Now, question arises, what determines the current state of the database? So the current state of the data means database means the data present in the database, along with any indices if you have built. Okay, so the optimization that the query rewriter does is not dependent on the database state. So yeah, I think I don't have that information here. So the example of the task that the query rewriter will do would be it will rewrite uh, um, a nested query or nested query into nested and correlated, right? Sometimes we also call correlated queries. So correlated nested queries are considered inefficient. So what query rewriter will do? Query rewriter will rewrite a nested correlated query. I think just correlated will be fine. A correlated query into a flat join based query. Okay, and then the flat query, which is non-correlated, is more efficient. So this kind of thing is done by query rewriter, which is a step towards the optimization of the query. Now comes query optimizer. So what query optimizer does? Query optimizer optimizes the query based upon the current database state. So again, I'm overemphasizing this because it is important. The query rewriter doesn't look at the database state in its optimization or rewriting the query, whereas query optimizer does look at the database state. So its optimization is based upon database state, which may involve the use of predefined index for faster and more efficient access of the data. Okay, so now the query optimizer has another important role, which is to come up with the query execution plans. All right, so query optimizer comes with various query execution plans and evaluates their cost in terms of the estimated number of I/O operation, the CPU processing cost, and the execution time. So let me rephrase it in an attempt to explain this point to you. Query optimizer, what it does, it comes with the several approaches to execute the query, right? So various execution plans means different approaches to execute the query. And for each approach, which we are calling as query execution plan, it will also have a cost attached to that query execution plan, like a Q1. Okay, Q1 will probably take N1 number of IO operations, right? And C1 number CPU processing time and T1 execution time. And you can have Q2 will say take N2 number of IO operation, C2 times of processing cost, and T2 execution time. So what query optimizer does for each query execution plan, it will have some estimated cost, and on the basis of this estimated cost, it will decide, the query optimizer will decide which query execution plan is to follow. Okay, now one thing that we need to remember about the cost that the query optimizer computes or estimates for each query execution plan is in fact an estimate. It's not the exact cost. Okay, so these are estimates based on the catalog information combined with the statistical inference, right? So yeah, this is slightly complex, which involves the statistical information as well as the information from the catalog. On that basis, the query optimizer will estimate the cost for each query execution plan. Now, query optimizer is a key competitive asset of a DBMS, right? So probably one of the most important component of a DBMS. All right, so what is it? It is the query optimizer, and query optimizer is present in the query processor. Okay, so now we come to the next module or next component of the query processor. This is query executor. Now what query executor does, the result of query optimization is a final execution plan. So out of the various possible execution plan based on the cost of each execution plan, query optimizer will come up with the final execution plan. And then this query executor, what it will do, query executor will take care of the actual execution by calling the storage manager to retrieve the data requested, right? So from the query processor, the last component is our query executor, which gets the final execution plan from query optimizer, and now it will reach out to the next component, which is storage manager, to access the data. So now we need to go to the storage manager. Now storage manager, what it does, storage manager governs the physical file access and supervises the correct and efficient storage of the data. Alright, so this is the module that will in reality access the data from the storage device. Now this guy also has various components. These components are transaction manager, buffer manager, log manager, and the recovery manager. Alright, so here these are 4 components, and we will look at these components one by one. What is transaction manager? What's the role of transaction manager? Well, I hope you remember the definition of transaction. It's a database application or database program that accesses the data in such a way that ACID, right? We discussed about ACID. Requirement: atomicity, consistency, isolation, and durability. So transaction manager supervises execution of database transaction. Okay, and here, as we have seen, a database transaction is a sequence of read and write operations which are considered to be atomic unit, right? That means either it will happen or will not happen at all. Okay, so what transaction manager has to do, the transaction manager has to create a schedule, right? In that schedule, it may have the interleaved read and write operations, but these interleaving of read and write operations is to be done intelligently so that the ACID requirements are satisfied. Yeah, here we go. The transaction manager guarantees ACID properties. Okay, so what it will do, it will create a schedule, right? And why is that schedule required? Well, we want a higher throughput, right? We want to support multiple transactions together, and that would be possible only if we could provide the parallel execution. or synchronous execution, but that could result into the violation of ACID. So we have this transaction manager which will come up with the schedule in such a way that we'll have the proper interleaving of read and write operations, and it will guarantee the ACID properties. Now, if the transaction is successful, then commit. So what transaction manager will do, will commit a transaction upon the successful execution and will issue a rollback if the transaction was unsuccessful, right? So if succeeded, good, we are good. We will notice, we will register the changes brought about by the transaction. If it was not successful, then we'll have to roll back to the previous situation. Alright, now let's move on to the next component of our storage manager, which is buffer manager. Now buffer manager manages buffer memory of the DBMS. Now buffer is the internal memory. Okay, and the internal memory is faster. So what is required in order to have the efficient access of the data is pre-hashed into the hash. Into the cache. And in the cache, that's the buffer we are referring to. So what buffer manager does, it intelligently caches the data into the buffer. All right. Now, the buffer will have the limited capacity, right? Nothing in comparison to your storage device. So we need some strategies for buffering. So the strategies which are employed are the data locality. What does it mean? It simply says that the data which is recently retrieved is likely to be retrieved again. Right, so this locality concept is very what I'll say kind of used in operating system as well, right? We do paging and virtual memory kind of thing. There also data locality is important. The temporal locality is also important. But anyway, here data locality can be exploited by the buffer manager because the data which is recently retrieved is likely to be retrieved again. So we'll keep that in the cache. Then we have 2080 law. What does it mean? Simply means that 80% of the transactions read only 20% of the data. All right, so that can also be exploited in the buffer by the buffer manager in caching the data into the buffer. Now, buffer manager also needs to have a smart replacement strategy. Why replacement? Well, in case your buffer is full, right, we need a data which is not present in the buffer, then yeah, the contents of the buffer need to be replaced with the content that we are searching for or retrieving. And the buffer manager will need the help from the lock manager. So buffer manager needs to interact with the lock manager. Now we'll have to look at the lock manager, what a lock manager does. So here we go. I did mention this thing that we need, or we are required to support multiple transactions, parallel transactions happening, or concurrent transactions happening. So if that is happening, we will have to make sure that this thing happens in the proper way, right? We have to support ACID. So for that, this lock manager comes to our rescue. So lock manager provides the concurrency control, which ensures that the data integrity is maintained at all the time. What is data integrity? Data integrity has to do with the correctness of the data. So that is enforced with the help of lock manager. So in a way, lock manager helps us with the concurrency control. So the mechanism of lock and all, probably you might have studied, or you may study in operating systems. Now there are two types of locks, the read and write lock. Okay, so on that basis, if you need the the locks are applied on the shared resources or the shared data. So if the user is requesting for read on the shared data, then we should provide what, the read lock. Otherwise, if the request is for writing the data or updating the data, then for that you need the write locks. Now this lock manager is responsible for assigning, releasing, and recording the locks in catalog. Now see, the catalog is coming here again. Okay, so if you remember, we had a statement in the previous lecture. We said that the catalog is the heart of a DBMS, right? So you'd see that catalog would appear in multiple discussions. So one more time, log manager, what it does is responsible for assigning, releasing, and recording logs in the catalog. So, well, for its complex task that the log manager performs, it makes use of a locking protocol, right? And what do we have in the locking protocol? It has the locking rules, and the log manager, what it does, it makes use of the locking protocol as well as a lock table, right? To assign and release the logs. Okay, so now let's look at the recovery manager. Recovery manager, what it does, it supervises the correct execution of database transaction. Now, what it will do, recovery manager keeps track of all the database operations in a log file. And what happens if required, if something goes wrong, right? Say there is a crash, right? So recovery manager will be called upon to undo actions or the about transactions during the crash. Okay, and that will be the recovery. So for crash recovery, recovery manager will have to take the action. It will have to undo those transactions that caused the crash. And then the DBMS also provides some utilities. So you're looking at some utilities provided by DBMS. So we have the loading utility, the organization utility, performance monitoring utilities, user management utilities, and backup and recovery utilities. So all these utilities are intuitive and self-explanatory. I'll give you a little bit of explanation. So loading utility is the utility that allows to load the data from Excel files or some other files, text files and all, or maybe from other databases. So loading utility allows to load the data into your database, which comes from diverse resources, could be from files or could be from other databases. Reorganization utility, well, it allows the data to be reorganized in such a way that it is more efficient. Now, performance monitoring utilities are used by DBA to monitor the performance of the database in terms of the response time, in terms of the throughput, right? Like how many transactions are happening per unit time, and also on the storage utilization. Okay, so these are the three KPIs, key performance indicators, right? So that was what the response time, the throughput, and then the usage, the storage usage. Now, user management utilities allows to create the users, to create the user groups, to give them the privileges, right privilege, read, write and read, all those kind of privileges. And backup and recovery utilities are kind of self-explanatory, right? If there is something something happens, say there's a failure, hardware failure, and some crash happens, you need to back up your data, you need to recover your data. For that also DBMS provides the utilities. All right, so I will stop right here, and I'll cover the next part of this topic in the next lecture. Bye bye, thank you, take care.